Like we began last time, let's start graphing this piecewise function by drawing a line where the invisible boundary is going to exist. And this time I can see that's occurring at 1. So let's make a dashed line when x is equal to 1, and we know something special is going to be happening at that location. Alright, so to begin graphing the piecewise function, let's just start with the top piece, I suppose. It says that the equation for this top piece is 3x. So I'm going to make an xy table, and this time it says the only number I can't pick for x is 1. And so actually, remember how we did in the last video, I always like to actually pick the boundary point as my x value, and then just make a note of whether or not this point actually exists on the graph. And since I can't actually pick one, remember that means I'm going to have an open circle at this location. But if x was 1, the y value would be 3. It just means I can't actually have a point there this time because x can't be 1. So if I plot that point, I can plot the point 1, or 1, 3. I'm just going to put an open circle right there, meaning that's where the point would be, except there's a hole there this time. So I need a couple more values that actually do exist on the line so I can graph it. Maybe I'll pick 2 for x, and maybe I'll pick 0 for x. You can pick anything you want for x besides 1. So if I plug in 2, I would get 6 as an output. 3 times 2 is 6. If I pick 0 for x, 0 times 0 is 0. So if I plot those 2 points, 0, 0 is a point, and you may be able to do this with slope-intercept form, and it's fine. It gets weird with these piecewise functions. And then the point 3, 6 is also a point. So actually my line is going to exist this way. I can draw that in with an arrow. It goes forever that direction. And my line's also going to exist this way. Those are all, oops, it's not a very straight line, but oh well. There's all the places where x is not 1, and so that's what my line is going to look like, just with a hole in it. But there's one more piece to this, and this time it says the second piece, well, it only gives me one value I'm allowed to pick for x. So in my xy table, I can only pick 1. It's the only option they give me. And really, I don't have any options for an output either. It's a constant this time. It says no matter what you pick for x, the output's always going to be y. So really, this second piece is just a point. It's the point 1 and then 4. Notice, if you watched the last video, you saw that hole got filled in with a point. This time it doesn't. The point exists above the line, and so my piecewise function is this line with a hole in it, and then a point up above it. These start to look really weird sometimes, but that is what my graph would look like. To answer these questions, at the bottom then, is the domain all reals? If you watched the last video, we said that means can you go anywhere on the x-axis, left or right, and will you always be able to find the graph above or below you? Do you have an output? The answer is yeah. This time every input has an output. Even if you get to where x is 1, it has a point, it's just above the line, the point's right there, but every output has an input. Or vice versa. Every input has an output. The next question, is it continuous? Means could you draw this graph without picking your pencil up off the paper? This time, no, you couldn't. There was that hole where the graph kind of jumps and then there's a point above it. So you'd have to pick up your pencil, meaning this graph is not continuous.